Hello. In this video, I'm gonna teaching you about solving some questions and also a little bit about PLC introduction and what is the PLC. But I have another video about the PLCs. It is full introduction about the PLCs, and also if you want to have more courses and classes, you can contact me. I can schedule the class for online class for you. Let's go to the first question. Question 1. Which characteristic best describe a properly functioning diode? So diode is best described for properly functioning diode. What is diode? You know what is diode. Let me to Google diode symbol. Diode symbol, copy image. So we have diode symbol. This is diode. This is from the anode to cathode. Is the conventional current flow. We assume that the current flow from the positive side of the circuit to the negative, but actually it is electrons that they go to the positive side. But in conventional current flow, we assume that it is from the anode side to the cathode side, and this is the diode. Diode is like a one-way road. They let the current to go from one way, but it's prohibited the current from another way, reverse way. We have forward bias and the reverse bias, and for forward bias we have the low resistance, but for reverse bias it is high resistance. And let's go to the options. High resistance in both directions is not correct. Low resistance in forward bias and high resistance in reverse bias. So low resistance in forward is correct, and high resistance in reverse bias is correct. But when the diode is on, when the voltage of the anode is more than the voltage of the cathode and the diode is on, so this option is correct, and the correct answer is this one. Let me to highlight this one. And high reverse current, no, it's not correct. And with low forward resistance, yeah, this one, low forward resistance, is correct, but the option is not correct. Low current forward flow in both directions, no, it's not correct. If the diode is shorted, yeah, it can be, but not in correct position in properly functioning diode. Question 2. Hydraulic lifting jack has a piston area of 50 square inches and is subjected to 400 psi pressure. What minimum load can it lift? So it says that we have 50 square inches, and for every inch we have 400 pound pressure. This is psi, pound per square inch. So for every inch of this 50 square inches, for every square inch of this 50, we have 400 psi. So for total, it's 50 multiple 400. So 550 multiple 400 is equal 23 zeros lb, pound. So this one is the correct answer. Let's go to the question 3. When serving equipment supplied by multiple energy source, when serving equipment supplied by multiple energy source, what must be included in log out procedure? So we have equipment, electrical equipment, and this equipment is very important. Maybe it's emergency equipment, or maybe for medical care or something. So it has different kind of energy sources. They supply this equipment. So when we want to maintain it, when we have maintenance, when we need to do something on it, so we need to cut off all of the energy sources, the power circuit only, only the highest voltage source, all energy sources supplying the equipment. Yeah, it can be. And the lowest voltage source, no. Question 4. After an electrical installation has been inspected, so how many additional inspections may be carried out if required? So we have construction, building something, dwelling unit or apartment, and or industrial or commercial, no different. So inspector coming and see something that is not correct, and he asks us to change it or fix it. So how many times he can do it? So many times, as long as the problem fixed. One additional inspection only? No further inspections allowed. Unlimited inspection as needed. We need to follow the instruction of the inspector and fix them. Question 5. Identify the logic gate shown in the diagram. Where is diagram? Let me logic gates symbols. Copy image. This question is not correct. It's not complete. So this is AND, this is OR, buffer, XOR, NAND, NOR, NOT. But at the question, at the Red Seal exam, most of the time we have for the test questions for the Red Seal exam, sometimes we have AND, OR, NOT, buffer, NAND, or NOR. So what is AND? Both of the inputs should be 1, and then we have 1 at the output. What is OR? One of them, if one of them is 1 out in the output, we can have 1. And what is NOT? If we have 1, we have 0 in the output. But if we have 0, it's 1 on the output. So NAND, what is NAND? It's AND plus NOT. What is NOR? It's OR plus NOT. And buffer. It's like a register. If we have 1 here, we have 1 here. If we have after a cycle also we have, because it's a register. Okay. And section 6. When working from an extension ladder, what is the highest rung that should be used for the standing? So it's about the extension ladder, and we can just stand in lower rungs, not the upper or the second rung. The correct answer is third rung. Depend on the safety rules, we can stand. Topest rung that we can stand is third rung. Question 7. At what stage can the final electrical inspection for a single dwelling be performed? So inspection for the single dwelling after rough in for final. This is important one. Final inspection. After rough-in inspection, after service energization, no. After roof and window are installed, no. After all electrical work has been completed, this one is correct one. After all electrical has been completed. Okay, question 8. A luminaire installed 8 meters above floor level must be serviced using an extension ladder. What is the safe procedure? So it is 8 meters above floor and service, so we should be safe. Climb using 2 points of the contact only, no. Secure the ladder and use the approved fall arrested harness. Yeah, this can be correct one, because we need to use fall protection equipments like fall arrest harness. Tie the ladder only, harness not recommended, no, because it's 8 meters, it's too high. And wear PPE only, no, not only. In which situation can pylon and yellow caution tape provide sufficient protection? So we need pylon yellow caution tapes around an open elevator shaft, around an unfinished window opening, around an open stairwells, no. All of these ones, no. Around cables laid temporarily on the floor for the conduit pulling. Yeah, this one is correct one. Okay. How often must high voltage rubber insulation gloves be electrically tested when in service? It's in service. While in service, how often high? So because it's in service, we use it. Sometimes we use it. Sometimes we put it in the warehouse or in the shelves. So we use it. When we use it, it's every 6 months, depending on the rule. But when we buy it from the store, from the shop, it can be every 12 months. I mean that for the first time, when you before the first usage of these gloves, insulation gloves, it can just be 12 months in the warehouse or in the store, not more than 12 months. If it's remained or it's not sold in the store for them 12 months, it needs again a test for insulation. Information related to HVAC piping is typically shown in which drawing set? HVAC and piping is mechanical drawings. Mechanical drawings is correct answer for HVAC system. Question 12. What minimum working current is required around exposed live electrical equipments operating on a 27.6 kilovolt three-phase Y system? So for this one, we have a table in Canadian Electrical Code Book. We have a table. You need to memorize these ones. You need to memorize a lot for this book, because you don't have enough time to search for everything. So you need to know that table 56 is about minimum working space. So just memorize table 56 working space. Table 56 working space. I have another video. In this video, I have 2 or 3 videos that I'm talking about general things in this book. And first of all, you need to memorize everything. But not everything. You need to memorize sections, the number of sections and the title of the sections. And also you need to memorize the title of the tables and the number of the tables. You need to know which table talking about the working space. Table 56. And then when you read the question, you can quickly come to the table 56 and find out it. But if you don't know the name of the number of the table or the title of the table, you need to go to the section or to the index in the back of the book or the first pages of the book in the context and search for the working space. Maybe you can find it, maybe not, and it takes time, and one question take you more than half an hour, and you don't have enough time for this question, for this exam. Electrician exam, 309A exam. It's not easy exam. You need to study more, and more than studying, and you need to know about the electrical phenomena. I have some videos about the electrical phenomena, about transformers, about motors, about the generators, about the induction motors. You can find about the voltage drop, about the capacitors, about the conduits, wirings, and you can use these videos to increase your knowledge about the improve your knowledge about the phenomenons about this book, and the electrician knowledge about the electrical engineering in the North America standards. But it's not enough. First of all, you need to memorize. You need to know that what is this tables and how you can find out. Okay, so let's go to the question. This question, 27.6 kilovolt three-phase Y system. Okay, so this is the Y system. This is a Y system, 27.6 kilovolt three-phase. This table, in this table, table 56, let me to write it, table 56, what is this about? It's about working clearance. Okay, so but this table telling you that about first column talking about the voltage, 0 to low voltage, and these ones high voltage, for example 25 kilovolt to 46 kilowatt, and the clearance working in space is 2.5 meter. But you need to know that for this question, this one Y system is important. You need to know about it. You need to be careful about it, because it says that it is Y system. So for Y system, if you just go and find for 27.6, 27, this one 2.5, so you'll choose 2.5. but this is Y system. Let me find Y electrical load. Copy. This is Y. This is like this. In the Y system, you have a point like this. It is neutral voltage and it's 0. So when it's telling you that it's 27.6 kilovolt, it's from this phase to this phase, 27. But or from here, or from here to here is 27, or from here to here, if you use meter, it's 27 kilovolt. But imagine that you have this load, and these parts are exposed. They are on bus bars or something, or they are exposed terminals. So imagine that you are coming from this side, and your foot is on the ground, and also this neutral is connected to the ground. So when you want to touch to this conductor, actually you see your body see the 27.6 divided by root of 3. Okay, so So because your foot, your body is grounded, and you need to be careful about this exposed conductor, or this exposed conductor, or this exposed conductor, because this part is the same level of the voltage with you. So because of that, we don't need to use this level of the voltage. We need to use this level of the voltage, 27.6 divide 1.732 is root of 3, and we can tell that 27.6 divide 1.7232, and it's 15.9. Imagine 16 kilovolt. 16 kilovolt. So in this table, again, we come here and it's 1.9. 16 table, 9K, 25K, and 16 cable also. 1.9 meter enough is enough. Minimum 1. So from this table, we can get for 15 or 16 kilovolt, we can get that 1.9 meter is enough. If we have more space, clearance space, is good working clearance, but at least we need 1.9 meter working clearance. So an AC alternator or generator is not producing output voltage. What is the most likely cause? What cause to generator or alternator, AC alternator, to producing the voltage or the power or the electricity? Worn brushes, faulty bearings, failure of the prime mover, damaged. You as an electrician, you know that for maintenance, you need to start from the most probable cause of something, cause of failure, or easiest part, or low cost of repairments. So you don't need to go, first of all, go and open the motors and or generator or alternator and check the brushes, or check the slip rings or faulty bearings. First of all, easy things, low cost thing, just check the prime mover, maybe it's not working. So this one is the right answer. And we need to go to the next one. VCE code table is used to determine the minimum copper conductor size for a field assembled grounding electrode. Which table? I know table 43. You need to know it. You need to memorize. If you want to pass the exam, you need to memorize all of the tables, all of the sections. It's better for you, because at this just you have 3 or 4 minutes for every question, and you need to save a lot of time for difficult question, for calculations, for some questions that they need a lot more time. So if you memorize, you know that the VCE code table is determined the minimum copper conductor size. Minimum copper conductor size for a field assembled grounding electrode. You want to make an electrode at the field. You have a wheel and you want to use a wheel for making electrode. How you use a copper conductor and make a circle and spiral, and you make electrode on the field side with it. So what is the minimum size of that copper conductor? It's depend on the current of that service. And let's go to the table 43. Table 43. 44, 40. You know that what is the table 44? It's for motor, 3-phase motors and their ampacity. What is table 45? It's for single phase mode AC motors. What is table 43? Table 43 is for minimum conductor field assembled grounding electrodes. Okay, so first column is about the ampacity of the service, and the second one is the minimum size of the conductor that we want to use it, bare copper conductor that we want to use it as an electrode. At least it should, there is a rule that tell us that it at least be 6 meters. And yeah, this is the question, table 43. Question 15, a natural gas heated apartment. So we heat this apartment with natural gas, not with electricity. Building contains 10 units. 10 units in this building. Each suite include an 8 kilowatt electric range and supply voltage in 120 to 40 volts single phase. So we have 8 kilowatt for each unit, and that's it. Natural. So this question doesn't talking about the square feet or square meter of this unit. So imagine each suite is 130 and 2 square meter. Okay, square meter. So you know that for every apartments, we have a rule that tell us for first 45 square meter we have 3,500 watt. For the next 45 square meter we need to assume 1,500 watt, and for the next 90 meters we need to, for each next 90 meters we need to 1,000 watt. Let me to show you the rule. You need to know that section 8, you need to memorize it. That section 8 is about this circuit loading and demand factors. It's about the panel sizing and the usage of the service, and calculate the demand factors and the calculation of the power usage, electricity power usage of the dwelling units, about the apartments, about the industries, about the hospitals, about the schools, everything. So for this one is for dwelling unit. The instructions for dwelling unit, calculate the load of the dwelling unit. And this one 8202, the rule 8202 is for apartments. So for apartments, calculation of the load of the apartments. So which rule tell us about the basic load 3,500 watt for the first 45 meters, an additional 1,500 watt for second 45 meters, and 1,000 watt for next 90 meters. So for this house, so what is the rule? 8202. 8202, the section 8, rule 202. And from this one you can figure out that this one, and from this one you can find out that one for 30 square meter you have 3,500, 1,500 and 1,000. So total is 5k and 6k, 6 kilowatt. So 6 kilowatt is the total of the It is about general consumers like lightnings, like outlets, receptacles, refrigerator, and some. And for this one, for the heater electric range, you can see for the apartment, electric range for the apartment, 6 kilowatt for the single range plus 40% of any amount by which the rating of the range exceeds 12 kilowatt. So we don't exceed 12 kilowatt, so we can imagine it as a 6 kilowatt. So which rule? 1A, I, triple I, one A, I, triple I, this one, and 822, 1AV, 1AV. This is 6 kilowatt for electric range. 6 kilowatt for electric range. Because it's 8 kilowatt, let me to write it 8 kilowatt. But from this rule, we know that we need to just calculate 6 kilowatt. So total is 6 plus 6 equal 12 kilowatt is total, and we need to calculate the ampacity. I for each unit is 12 divided to 40 volts. Let me to write 0 to 0 to 40 volts, and it's equal to divide to 40, 50 amps. But it's not correct answer. It's not good. 50 amps. We have another rule, a sub rule actually here. In this sub rule for B, part A, not part A, for part B, it says that at least we need to assume 60 amps for every unit. If all of these calculations are less than 60 amp, at least we need to imagine 60 amps. Look at here, creator of item A or B. So because of sub rule A to 2 1 B, because of that 60 amp, and then we need to go to the table. It's copper is 75 centigrade, and so we need to check table 2 for size the cable sizing. It's 60 amp and 75, and copper 75 60 amps, so it's cable size 6 AWG. So table 2 6 AWG. Okay, this is the correct answer. Okay, And that's it. I hope that these questions, some of them, most of them was general rule, general knowledge. You need to know about some phenomenons about the electricity, electricity phenomenons, and these ones can help you to pass your exam, because these are this kind of question like this: all energy sources supply need be to cut, or like this: unlimited inspection as need. You can find this. This is in section 2, I think. And these ones are easy ones. Or you just need to about the logic gates, and you don't need to do a lot of calculations or something, or searching in the book. So these ones are easy ones, and we solve some questions, some like these ones. And yeah, for this exam you need to be prepared. You need to know about the phenomenons. You need to be smart about everything in this book, and memorize some things. And if you want to have an online class with me, you can contact me and ask me for a schedule online class for you. But in this part, I want to have just look at to the PLC and what is PLC in some questions, maybe 2, 3, or sometimes 5 questions related to the PLC in this exam, in the electrician exam. And they are related to control boards, control circuits, but not all of them related to the control. You need to know about the control circuits, and also more than it, you need to about the PLC, Programmable Logic Controller. So what is PLC? PLCs are like CPUs, like processor. They help you to shrink the control circuits. You don't need to use a lot of relays and a lot of wires, a lot of electrical equipments in your panels. Just one PLC can help you to reduce a lot of equipments, and it's easy to maintenance. So for PLC, we have a processor inside. We have memory unit. We have input unit. We have output unit. We have some indicators for some situations. We have some buttons for programming with the PLC, and also there is some ports for connecting to the laptop and push the program logic to the PLC. And it needs also to the power. Most of the time is 24 DC volt. So why electricians should learn PLC? First of all, you need to pass your exam, and this kind of question can help you to pass the exam easily, because most of the time they are not too difficult questions. If you know about them, if you learn about the PLC, if you study about the PLCs, they are easy questions, because they don't take a lot of time for calculations or something, or searching in the book. You just need to know about them. You need to know about the PLCs. I'll record another video about the PLCs, about how to program them, logic ladder, schematics, and you can watch about and learn about and study about the PLCs with my videos. Modern factories and automation systems rely on the PLCs. Big factories, automation, and automation buildings, or BMS, AMS, all of them, ABS, all of them needs PLCs. Electricians who understand PLC can troubleshoot faster. As an electrician, if you know about the PLCs, it's not too much difficult. PLCs is but most of 90% of the electricians don't know about the PLCs, but it's not too much difficult. I'll teach you how to learn about the PLCs and work with them, and it can be a big asset for you. So First of all, it helps you to pass your exam. There is a brain or processor, famous brands, Siemens, ABB, Schneider. What is the PLC? Programming Logic Controller, a programmable logic controller, and industrial computer. It's a industrial like microcontrollers, like FPGAs, like CPUs, like GPUs, like memory units, like digital circuits. But it's industrial. You have yeah, it's reliable. Most important thing about the PLCs is that they are reliable processors. So because in industries you need the devices and circuits and control circuits and everything working reliably. In replace large relays logic panels with software logic. Yeah, you can program, you can use your laptop and program the PLC easily. Core concepts: logic processing, like brain, input part and output parts. What are the inputs? Like push buttons, like start button, like stop button, like jogging, like sensors, like detectors, like limit switches. They are inputs and they come to the PLC, Programmable Logic Controller, and then we have some processing on them. How the processor know that what should it do with the inputs, with your program. Your program coming from your laptop, go from your laptop to the PLC, like this. You connect your laptop with a cable, Ethernet cable, or different kind of cables for different brands, and you tell to the processor of or memories or the processor of the PLC what to do with the inputs. So you have inputs, you have, and then what are the outputs? What are them? They are like motors, like lightings, like flashing, like blowers, like contactors, everything, actuators, and that's it. So again, processor, output, and input is PLC, and the ladder. All relay systems vs PLC systems, or if you don't use PLCs, big panels. You need big panels for a lot of wires, a lot of connector terminations, a lot of relays and contactors, everything. But here, all in PLC a little bit, and you program with your laptop with your programming ladder diagram. I'll teach you in another video. Just be with my channel, subscribe to my channel, and you can find out a lot about PLC programming easily. Not too much hard. It's easy, and you can find out better jobs, better salary. So it's ladder. It's like contactor, normally open contactor, normally closed contactor. Relays, normally open is hold contacts, and is start push button, and that's it. It's like control circuits, and you program the PLC. Yeah, that's it. Okay, thank you. I hope that this video be useful for you, and try to study more, try to memorize, try to see more questions. It's very important to see more and more questions. After that, you can understand what kind of question you will have in your exam. So I have some more question videos about different kind of questions about different part of this Canadian Electrical Code Book, and sections, about the tables. You can find out. I recorded some videos about the tables. I introduce the tables, the name of the tables, and how you can use them. Also, if you need online classes, you can contact me. Thank you. Have a good day.